Okay, so when I said I was going to give you a test, what I meant was I was going to give you the second derivative test.
Second one, you mean I missed the first?
It's a test of the test of the test.
Okay, so the first derivative test is for checking whether something's a critical point, right? Like the idea of a first derivative test is you take the derivative, you set it equal to 0, you solve, you check the undefined points, and that gets you this list of critical points. You guys see that? So this is assuming that I have done that. I have like over here some kind of list of critical points. You guys cool with that? So like, I might have a whole list of points. And what I need to decide is which ones are local maxes, which ones are local mins, and which ones are saddles. Okay? So I need to calculate a thing first. Cool? And the thing you have to calculate is this magic D. Get the notation exactly right here. D. Okay? So D is categorically a function of x and y depending on f. Okay? So this is a function of x and y and a function of the function f that you're calculating with. Does that make sense? In the same way, a derivative, right? Like f prime is a function of x that kind of depends on what you were differentiating, right? So to calculate this thing, you do fxx of x and y plus fyy of x and y. And then you do the weirdest possible thing. You subtract off fxy of x and y squared, of course.
Wait, don't you multiply those two?
Yeah, obviously you multiply those. Why would I be such an idiot?
And those aren't divided by 2 anymore?
Those are not divided by 2 anymore. The dividing by 2 is a Taylor series thing, not a thing intrinsic to second derivatives. You guys want a way to remember this sucker? Okay, so the way to remember this sucker is that it's the derivative, or the determinant of fxx, fxy, fyx, and fyy.
I mean,
You remember the thing we did for cross products, right?
Yeah.
Where you do this diagonal minus that diagonal?
Okay.
Same thing here. You guys cool with this?
I did linear
Now,
this now.
Why is there this squaring here?
Because they end up being multiplied because they're diagonal to each other.
But why don't I have fyx of x and y times f?
As far as we care, they're the same thing.
Good, because Claros, right? Okay, so you calculate this number. This isn't really a number, right? So how do we make this thing into a number?
In
You have values for x and y.
Yeah, I should evaluate this at your critical point, right? So this is all going to be if D evaluated at A and B. And I'm just going to someplace up here, right, assume A, B is a critical point. Okay? Good? Probably not going to have a lot of luck calculating D if what? Good? If you don't have a function, right? Like if you don't have a formula for your function, you're not going to have a hell of a lot of luck here.
If the first derivative partials are not differentiable.
Yeah, you guys see that? Like if I got this thing as a critical point because the first derivatives weren't defined there, I'm not going to get a second derivative there, right?
Oh.
Right. So this is going to be good for the ones where the tangent plane's horizontal, right? Not for the ones where the tangent plane is all jacked up. what are you going to do when you figure out that you've got one of these spots where the tangent plane's all jacked up?
Look at the graph.
Yeah. You could take the graph and look, or you could plug that point into the function and then compare it to points nearby, right?
So it's like when you kind of have like values on either side, you kind of like bring them closer.
Yeah, you could try that, right? That's a good idea. You could like evaluate it against the other things. It's just tougher, right? And there's a spot in this test for if this thing doesn't work, then you know nothing anyway. You guys cool with that? So like there's an inconclusive even at the bottom of this test. And I'll show you why that thing exists in a sec. So what category of object is D evaluated at A and B?
That's a number. You get points.
Good. That's a number, right? Because I put in some points. And then all I care about is whether that number is positive. Okay, and there's going to be 3 cases here, 4 cases. So there's going to be if it's positive, I know that seems dumb.
Maybe 2 negatives.
If it's negative, and if it's actually 0. Okay, so what I would like you to think is that this thing is a little analogous to the second derivative test in Calc 1. Do you guys remember the second derivative test in Calc 1? Maybe?
Yeah, I think so.
You think so? How does the second derivative test in Calc 1
I
work?
know what that's supposed to do.
You guys are all mumble. Should that be the quiz today? Should I make
So,
you write down the
If
second
it's
derivative?
greater than 0, then you have a minimum. If it's less than 0, you have a, is that weird?
It's concave up first.
That's what I
It's
want.
concave.
So
Yeah.
you get a critical point, right? And then you check the concavity there. If it's concave up, you have a
Positive.
Minimum.
minimum. And if it's concave down, you have a
Maximum.
maximum, right? So this is similar. If it's not concave anything, what do you know?
Saddle.
Yeah.
You don't know that it's a saddle necessarily, you just don't friggin' know. It's too flat. Do you guys want an example for that?
Horizontal line.
Like x to the 4th is one of those. Right? If you take the second derivative of x to the 4th, you get
12x squared.
some x squared, right? So when you evaluate that at the critical point 0, you get 0, right? The difference between x to the 4th and minus x to the 4th is whether it's a max or a min, right? You guys with me? But you can't tell in the concavity because the concavity is 0 there anyway, right? Regardless of whether you have 12x squared or minus 12x squared, when you evaluate at 0, you still get 0. So this guy, if d is 0, that's your, don't know. This is kind of the test was inconclusive, you don't know anything.
Would that be where you would start plugging in points, or is that just like done and it's not going to work?
I don't know, it depends on how bad you want this answer. Right, if the reward for classify the extrema is like a pat on the back, I might stop there. I'd be like, I don't know, this is hard. If the reward for classify the extrema is that I get paid this month, I'm gonna do something else. Right, like I'm gonna go plug this into Wolfram Alpha and start dropping some dots on this thing. Or I'm gonna write a Python program that's gonna seed 1,000,000 points next to this thing. And calculate the values and just pop a red flag or a green flag if it's a max or a min or whatever.
Thought variable.
You guys cool with that? You should take programming 1, by the way. Because being able to write that piece of Python script is a super good idea. It only takes about 5 minutes to write the program. But only if you know how to write the program.
Yeah, it's class. We still should program.
You should have been better at it. You should take programming 2. All right, hang on. So I have to give you the rest of this. So if if this D thing evaluated at A and B is positive, that's going to be one of your you get an answer things. Okay? Once you get to positive, you need to check one of the other second derivatives. So this is like, concavity's going to do a good job telling you. Now check the concavity. So this is going to be if, and it doesn't matter whether you check fxx, oops, one just spelled if. Oh, that's why I spelled if funny. I meant and if. Fxx is positive. That means I've got a concave up thing, and concavity is doing a good job, so that should be a minimum. Guess roll that. Okay, so if D evaluated at A and B is bigger than 0, and if fxx is less than 0,
That's where a saddle is.
nope,
No.
that's concavity's doing a good job, and it's concave down,
Oh, okay, yeah.
so that's going to give you a maximum.
Now, would you be able to do the same thing then with FYY?
Yeah, you could certainly do these with, so instead of fxx, you could calculate with fyy.
Like if they were easier, we wouldn't have to look at the x's?
Yeah, like if fyy is 2 and fxx is some messy, horrible function of x and y, go with the one that's easy.
So would it be like with the FYY greater than 0 local max, and then if the FXX is local min, that would be the saddle?
Close. Yeah, so if you had fyy is positive and fxx is negative,
Yeah,
then yeah, you automatically have a saddle.
that's what I said. I just,
And you'll automatically get a saddle up here, right?
mhm.
Because this will be a positive times a negative minus something. That's going to be negative. That's going to kick me into this case. If you evaluate D and it's negative, what do you get?
A saddle?
Perfect.
Okay, so that's how it works.
Okay, keep in mind, these are all for what thing? Like, what's a local minimum here?
Just the point at B, right?
Yeah, just the point you evaluated D at, right? So you're going to have a whole list of critical points, like 4 or 5 of them maybe. Then you're going to calculate D at each one of these. And you're going to classify each one of them separately. Does that make sense? You can't do this at one point and get like global knowledge.
But that would just be plugging points into your,
Yeah, you're just going to plug points into this formula.
You wrote FYY is greater than 0 on the bottom.
what's that one?
I did. And I meant negative.
So you wrote down that that's a saddle, but would we answer that as it's a saddle, or just it's not a max or min?
So if D is negative,
Yeah,
then it's a saddle. You can write is not a local max or min.
okay.
That's totally fine. I like knowing that it's also a critical point. Right? Because like lots of shit isn't a local max or a min.
Yeah.
Like if you pull a point out of the plane, with probability 1, it's probably, oh, okay. So given a reasonable function, no, this is a terrible statement. I can't say this with any degree of certainty. If you have a nice function and you pull a random point out of the plane, it's probably not anything, right? Like it's just the side of this handkerchief. It's not the top of anything. It's not the bottom of anything. It's just kind of a point on the hillside. Who cares? But these guys are special, right?
Yeah.
Because the tangent plate's horizontal there. That's big information. And then the saddleness is weird.
Does the fxy, is that related in any way to the concavity along the line y equals x or y equals negative x or anything?
So that's the, right, this is the rate of change of the x derivative in the y direction. So that's the rate at which the lines are twisting.
Ah, okay.
You guys see that? It should not, like, this, the fact that this quantity gives you usable information is not obvious in any way. This goes back to a thing about how I can't even say all of these words.
Where would we
Yeah.
learn about that determinant? Which,
We'll talk about something related to this determinant when we do change of variables. U substitution. Do you guys remember U substitution in Calc 1? Or Calc 2 maybe? So we're going to do an analogy to U substitution that's going to be a little bit funky.
Is that like with the UV, or is that just like?
Yeah, we're going to change both variables, right? We're going to do some way to turn X's and Y's into U's and V's. We're going to do a bunch of these things. Some of them are really obvious, some of them are a little bit weird, and then the general one is really funky. To do a good job with the general one, I need to have linear algebra, but I don't have linear algebra yet, so we're going to do kind of a bad job with the general one, and then I'll wave my hands at that and be like, remember that thing where we did the second derivative test? It's like that. And you'll all believe me because you'll be super used to using this. But I'm totally lying to you about it. This is a thing called a Wronski, and it's not super easy to understand. It's a ways out. Trust me for now. Cool?
For shits and giggles, could you give us some examples of functions where that second derivative test does not work?
Oh, where this thing doesn't work?
Yeah.
Oh, you mean where this happens?
Yeah.
Well, no.
Or were you gonna
when
s-
if you tried to apply that, you would, you know, for functions for which that test might not.
Reality breaks
Yeah.
down
like
and
if you
nothing
can't
works.
get there, like maybe.
Oh, sure, like things where I couldn't even get to this.
Where you couldn't get
Yeah,
there.
we can try a couple.